So we're going to try to finish up this 1-6. We got pretty good ways through it yesterday, but hopefully we'll do it today. Like you just told me, let's see if this thing works. First of all, forgot to do this. All right, and hopefully it makes nice round circles. Yep. So we did that polygon, right? What was it? Was it a pentagon, or it doesn't matter? Let's just go to polygon. Let's make it a pentagon. There we go. Let's make it 5 sides. That's a pentagon. And there we go. All right, we're going to name it just like we did yesterday. This is where we left off yesterday, A, B, C, D, E. And again, we could call it polygon A, B, C, D, E. We could call it pentagon A, B, C, D, E. Just a little review from yesterday. We don't have to start at A. You can start at any of these letters. Okay, the one thing that you cannot name it, everybody watching? The one thing that you cannot name it, like let's say we started at A again. Okay, I can only go from A to B and then around, or I could go the other way. I could go from A to E and around. So I could call this A, B, C, D, E, or I could call it A, E, D, C, B. I cannot call it A, D, anything, okay? You can't just skip across one of these points. You have to go to what they call a consecutive vertex. Consecutive means one right after the other, all right? So is D right after A? No. What is right after A? Either B or E, right, okay? So I got to go consecutively. You hear that word? All right, I got to go consecutively. That's the last thing we talked about. One thing we're going to talk about right now is we're not really going to do anything with this in this lesson, okay? We're just going to teach you the word, but there is another lesson, right, where we're going to use this. I can't remember I don't think it's in this chapter. In fact, I know it's not in this chapter. I don't know what chapter, I forget. It's probably chapter 3 or so. It's fairly soon. But we're going to do stuff with what we're going to talk about right now. But this is just vocab. It's just so that you know the names of the words. So what I'm going to do is this. I'm going to draw a line segment from any point. Doesn't matter which one you start with, okay? I'll start at A, but it doesn't matter which one you start with. And I'm going to draw a line segment to non-consecutive vertices. We just talked about consecutive. What does consecutive mean? One right after what? The other, okay? So now I'm going to go a little different. I'm going to draw a line segment from any point. I'll start at A, and I'll go to the non-consecutive vertices. So does that mean I go to E? No, because that's consecutive. Right, D or C. Very good. All right, so let's go to D first. Okay, so that's a non-consecutive vertex. And then let's start at A again. Stay with that same vertex. And we're going to go to the next non-consecutive vertex. What would that be? That would be C. These two lines right here have names. Okay, if you go from any point, I could have started at E, I could have started at D, C, or B. It doesn't matter. I just decided to start at A. And if I draw consecutive, if I draw line segments to a non-consecutive vertex, that's what it would look like. And these things are called diagonals. You've probably heard of that word diagonal before, but this is a very specific type of thing. A very specific type of diagonal. All right? Now there's more. I mean, we could do, well, from that point right there, there's no more. But let's say, let's go a different color. Let's say we start at another letter. I don't know, E. What's the non-consecutive vertices from E? B and C. Very good. So from B to C, E to C. All right? So those would be diagonals as well. Okay? Either one of these. EB would be a diagonal. EC would be a diagonal from where? From point E. That's right. Everybody good with diagonals? Yeah, that's all it is. Right now, the only thing we need to worry about is the name. All right? We're going to deal with diagonals later on. In fact, we're going to use diagonals in order to figure out what each of these angles are equal to. Like if this was a regular pentagon, which means what? We talked about this yesterday. If it's regular, it means all the sides are equal and all the angles are equal. Good. if this is a regular pentagon, we can do some math. I'm not going to do it now. We'll wait till that we hit it in another chapter. But we could do some math and find out exactly how much each of these angles are equal to. All right? Which is kind of cool, I think. But we'll wait till later to do that. All right. Let's do another thing. Let's talk a little bit about triangles now. All right? We already talked about a triangle. A triangle has how many sides? 3 sides, and everybody would have known that. Even day one, when you first walked into this room, you could have told me that a triangle has 3 sides, I would guess. There's a lot of things to know about triangles, a lot of stuff. You just would not believe how much there is to know about triangles. We're just going to scratch the surface today, right? We're just going to hit a couple things. Yeah, and then we're going to actually talk about circles a little bit later after this. We talked very briefly about circles earlier yesterday. We're going to hit more circles, but right now we're going to do triangles. So if I wanted to name this, I think I already told you this yesterday anyway, but if I wanted to name that triangle, we have a little symbol. Do you remember the symbol for triangle? Yeah, it's just a little triangle. It's a little equilateral, equiangular triangle, okay? That's the symbol for triangle. Just because it looks like this, you don't have to draw that triangle that looks like this. You just draw this symbol every single time it's a triangle. And then we use the 3 letters that are in the triangle. Again, it doesn't matter which one you start with. I'll probably call this triangle ABC. Now, if you look at a triangle, does it matter which way you go? No, I could call it ABC. I could call it what? ACB. All right, could call it BCA, CBA, bunch of different things that I could name that triangle. I'm just going to use triangle ABC. On a quiz or a test, if I ask you to name a triangle, you must have the triangle symbol in front of it. Is everybody listening to me? Yeah, I don't know if you are or not. Because on the quiz, I said if I ask for a line, you have to have the line symbol over top of it. Several people did not do that. If I ask for an angle, you must have the what? The angle symbol in front of it. Okay? Many of you did not. And you got it wrong on the quiz. All right? So I'm saying this, and I'm hoping you're writing this down. I'm hoping you remember it. But when I ask for a triangle, you must have the triangle symbol in front of it. Don't just put ABC. Everybody good? Good. All right. Now, let's talk about a couple words here. Again, this first chapter is just laying the foundation. That's all it is. We're just learning what these words mean. Later on in other chapters, we're going to do some stuff with it. And we're going to actually do some math and all that kind of thing. So let's talk about this word, and it's called opposite. Everybody knows what opposite is, but in reference to this triangle. So we're not just going to talk opposite, we're going to talk about opposite sides, and we're going to talk about opposite, what do you think? Angles. Very good. All right. All right, so let's talk about this. Let's take a look at angle A. We'll start there. Okay, there's angle A. What if I asked you to tell me the opposite side to angle A? What side is opposite angle A? Okay, it's not B and C. It's a side, so it's a line segment. So how would we say it? Yes, you would say line segment BC. Very good. Or if you wanted to say side BC, I would know what you're talking about. So check this out. So to see how this side is opposite angle A? In fact, that side right here doesn't have any of angle A in it, does it? See angle A? It goes from AB to AC, right? BC doesn't have A in it at all, so it's opposite, right? Doesn't have a part of it at all. So that's how you know if it's opposite, all right? It's just right across from it. It's pretty easy. You see that arrow? Okay, it means it's right across from it. So what if I asked you angle... Let's do this. Well, it doesn't matter what order you put it in. We'll just say this. We'll say that BC, line segment BC, is what? Opposite of point A. Let's do the other ones. What are the other sides? So I got BC. Let's go the other way. Let's start at AB. Line segment AB. What is it opposite of? That's it, point C. Everybody see AB? All right. And what is it opposite? It's opposite point C, or angle C, I should say. Yeah, I should have put angle there. Sorry about that. Angle A is opposite of angle C. What's the third side? We got BC, we got AB. What's the other side? AC. So we got line segment AC, and that's opposite. What is again AC? Here's AC. What angle is opposite AC? Angle B, because B is not a part of AC, is it? All right. So AC is opposite angle B. So make sure you know what those mean. I could go the other way, like I did at the beginning. What's opposite angle A? Line segment BC. What's opposite angle C? Line segment AB. It goes both ways. All right. Again, it's just another word. Just learning some vocab here. We're learning what opposite sides are, and we're learning what opposite angles are. Again, this is going to be used over and over again throughout the book. Got heads down. I'm going to send people to the office. I got my phone out. I'm about to text Mrs. Schrader, okay, to tell her that you're coming to the office. It's out. It's ready. It's right there, okay? I'm tired of threatening, okay? I want your head up. I want your eyes up here. It's not that difficult. Just write the stuff down, all right? This is what you do in school, all right? You take notes, you watch the teacher, you listen to them, you write stuff down, you ask questions, you answer questions. That's what you're supposed to be doing. All right, enough of that. Here's another word. Believe me, I know you get tired of me saying all this stuff and getting on your case about it, but you're not as tired of it as I am. Believe me, because I say it in so many classes. Not really my honors classes. I rarely, maybe one or two people, but here's a word. So people can stay awake, all right? I've seen it. And most of you guys are. The vast majority. All right, the word perimeter. The perimeter just means the distance around something. The distance around. They say this, a closed figure. It's probably a better way to say it. Okay, the distance around a closed figure. So when I think of perimeter, I basically just think the distance around something, right? The distance around it. So for instance, let's do that triangle again. Right there and right there. What if, and again, we'll make it real simple, ABC. What if this is 3, this is 5, and this is 8? I don't know. It's not exactly to scale, but that's okay, right? And let's say this was 3 inches, this is 5 inches, and this was 8 inches, okay? And I asked you to find the perimeter of it. So the question would say, find the perimeter of, it's a triangle, so put the triangle symbol, ABC. Right? So there is your, there's your question. And they give you this, okay? They give it to you. It's in the book, it's in the homework or whatever. Right? So what would you do? How would you find the perimeter of it? Add them all up. That's right. If you want to find the distance around the thing, let's say you were going to walk around it and you started here. Well, walking 3 inches is not that far, okay? But whatever, you get the idea, right? What if I went 3 inches this way, then 5 inches this way, then 8 inches this way? It's 3 plus what? 5 plus 8, which equals 16, because 3 plus 5 is 8, plus 8 is 16. 16 what, though? 16 inches, okay? Don't just put 16. If they give you units like this, don't just write the number. Write the units in there, okay? If it's feet, miles, meters, centimeters, whatever it is, okay, put the units in there, all right? So the perimeter, here's how I would write it. P equals 16 inches. If I was to write this on a quiz or a test, right, even your homework, get used to it on the homework, then write it like this. That means perimeter. P for perimeter equals 16 inches. We just add up the lengths of the sides. Very, very simple. They give you a formula for this one thing. I'm not going to do that. I just think it's too confusing. But I will do an example. Let's go back to whites. I will do an example. Come on, click. There we go. And let's do the pentagon again. Now, I drew this on the computer, and so all the angles and all the sides are equal to each other. We mentioned this once already today. What do we call it if all the sides and angles are equal to each other? It's a what kind of polygon or what kind of pentagon? Well, all the sides and all the angles are equal, so we call it a regular polygon. This is a regular polygon. In this case, there's 5 sides, so it's a regular what kind of gon? Pentagon. Okay, it's a pentagon. So what if I told you this? I didn't put any units on it, but it says find the perimeter. I'm not going to write it. Wrote it on the other one. It says find the perimeter. You could sit there and add 9 how many times? 5 times. But there's a better way to do that. What's a better way to do that? Just 9 times 5. Exactly right. So just go 9 times 5. Since they're all exactly the same. Now they do give you a little formula. I'll just give it to you. It's the perimeter. Let's see, how do they write it? And S. Okay. What is that? It doesn't matter. I said there's no units on it, so you don't need units. If I don't put units on there, you don't have to put units. Just so that I write what's in the book. All right, so if you look in the book, you're like, oh, he didn't go over that. What does this mean right here? Perimeter, right, equals N means how many sides that you have. S is the length of each side, okay? Do you really have to memorize that formula? No, because you know if all these are exactly the same, what do? You just multiply 9 times how many you got, right? And so what is that? That's 45. There's no units on it, so you don't have to put any units. So I would write P equals 45. That's as simple as that. Is there any reason to do this? That would just be a waste of time, wouldn't it? Okay. I mean, you could do that. Wouldn't be wrong. But man, this is so much quicker and easier. Yeah. That's only if they're exactly the same. If they're not exactly the same, then you would just add them all up. Everybody go with that? All right. Let's talk about circles now. And we got some words. And let's draw a nice big circle. And I'm going to draw some stuff in there. Again, this is all vocab. It's all vocabulary. Well, with that perimeter, you can absolutely do some math with that perimeter stuff, okay? But with this thing right here, this right here is basically just, well, we're going to use this to do some math. All right, let's talk about it. Let's go to a different color. Go to yellow. Shows up pretty good. All right, what if I did this? Well, first of all, what's that point right there in the middle? Talked about this yesterday. It's the center of the circle. That's right. All right, but what if I did this? What if I connected just 2 points on the circle? There's a point right there. There's a point right there. Okay, Zion says the radius, but it's not the radius. We are going to talk about radius. It is going to be one of our words, but this is not the radius. It's probably a word that you probably have not been taught before, so I'll just give it to you. If you connect any 2 points on a circle, it's not the diameter. It's called a chord. All right, C-H-O-R-D. Like in music, they have chords, right? You got a D chord, a G chord, an A chord, that kind of thing. That's the same spelling, right? But it's not like a chord, like a rope, right? Sometimes is a chord. That would be C-O-R-D. This is C-H-O-R-D. All right, so that's a chord. Let's draw another chord. How could I draw another chord? Well, anywhere from one point on a circle to another point on a circle. What would that yellow one be called? That's also a chord. Okay, let's do this. Let's draw another chord. I'll make this a different color because there's something special about this chord. All right, look at that blue one right there. It does go through the center. That's what's special about this one. So we give it a different name. If it goes through the center.
Sorry to interrupt you. Can you send Christopher to the office for a dismissal?
Who is that?
Christopher.
I don't. Oh, okay, Chris. All right. I wasn't thinking Christopher. All right. So here we go. Look at this one. Check out the video and look for the homework. Okay, I gave you the. I just gave you the lesson plan thing, so make sure you get those done. All right, so look at this blue one. This blue one goes through the center of the circle. It's got a special name, and we call that the diameter. Okay, is there only one diameter? Nope, you could have a ton of diameters. I'll tell you what, let's just keep it blue. All right, I could draw another diameter. What's it have to do? It's got to start on the circle, go through the center, and end on the circle. If it goes out like this, that's not the diameter. Everybody see that? If it stops in here, it's not the diameter. If it stops at the center, that's not the diameter. All right? It's got to go from one point of the circle to the end of the circle and go through the center. That's another diameter. What about the length of these diameters? Are they going to be any different? Those two blue ones, are they going to be the same length or are they going to be different lengths? Alani, you with me? It's going to be the same. That's right. The diameters have the same length. Every diameter in this circle that I would draw. And I can draw a ton of diameters in that circle. In fact, I could draw an infinite number if I wanted to. Well, I wouldn't be able to live that long to draw an infinite. But what about a chord? Is a chord always the same length? No, because, let me show you this. They kind of look the same length. This one looks a little bit longer, doesn't it? But watch, I could draw another chord like from here to here. That's obviously not the same length as this one or this one. So chords can be different lengths, but the diameter in a particular circle is always the same length. Right? Somebody said a word earlier that we're going to use right now. Do it in a different color. This one, it does not connect two points of the circle. All right? This one starts at the center and just goes to any point, it doesn't matter where, any point on the circle. All right? So there's one right there. What do we call that? If it starts at the center, it goes to a point on the circle. It's the radius of the circle. Tell me something about the radius of the circle compared to the diameter of the circle.
The diameter starts on the circle.
Well, what about the distance, the length of it? Okay, the diameter is longer, that's true. I don't understand why you're talking. I'm trying to teach something here. Go ahead, Penny. Yeah, the diameter goes to the whole entire circle. So that pink one right there, that whole pink one is the what? Like if I let go of that, what's that whole pink one? Is it still the radius? No, it's the what? Diameter. But what if I took that diameter and got to grab the end of it. There we go. What if I took it to the center of the circle? How long is it compared to, how long is that radius compared to the diameter? It's half of it, exactly half. Everybody hear that? All right, that's really important. So, let's write this down. So the diameter, so one diameter is equal to how many radii? Remember, radii is the plural of radius. So one diameter is how many radii? Two. Two radii. Okay? Or you could say one radius. Why did I go to radius and I said radii for this one? Because this is just what? One, and one, a singular, is just radius, okay? So one radius is equal to how much of the diameter? You guys said it earlier, and you're right, it's a half. Okay, you can go either way. You got me on that? Okay. Let's do another word that we're going to use later on. We're not going to really do much with today. Let's put this in red. Got a lot of stuff on this circle. I'm going to make this a little bit thicker, so watch this. What if I went from this chord to this chord, but I went along the circle. Everybody watching? See that right there? Is that a chord? It connects 2 points, doesn't it? On a circle, but it's not a straight line, right? It goes around the circle. It's a curve. So we actually have a name for that, and that is called an arc. When we start talking about circles, we're going to talk about arcs a lot. All right, so this is an arc. All right, there's a bunch of arcs on here, right? Any from one point to another point on the circle, if you go around the circle, that's considered to be an arc. So that's another thing that's really important. Let's talk about the arc for a second. Let's label it. Let's call it AB. I'm tired of AB. Let's go ZY for Zion Young. All right. So this is ZY right here. Arc ZY. This is how we label an arc. You know how to label a chord. It's a line segment. How do you label a chord? With a what? With just a little line on top, right? With no arrows, because it's a line segment. Okay. A radius is a line segment. A diameter is a line segment. So all those straight lines are line segments. This is not a straight line. This is a curve, isn't it? Or it's a what? It's an arc. All right. This is how we do an arc. So we use 2 letters. Okay. It doesn't matter what order you go in. ZY. All right. And then watch. Here's how we label an arc. Let's make it a little curvy. Okay, like that. See, it's just a little curved thing over top of it. And that means what? That means, doesn't mean circle. It means arc. I've been saying arc for the last 20 times, okay? It's an arc, what? ZY. This is how we would say it. This is how we would write it, okay? So that's pretty important. Let's do this. You know how I did 1 diameter equals 2 radii? Let's write it like this. I should have done this earlier. So 1 diameter, I'll just put D, equals how many radii? 2. 2r. So that's kind of important. You don't really necessarily have to memorize that, but if you know the diameter is twice as big as the radius, we could always replace diameter with 2r. That's going to come into play in just a minute here. All right? Let's see. Let's talk about, we talked about perimeter earlier, didn't we? It's the what? It's the distance. What is it? The distance around something, okay? The distance around. So, is this a closed figure? That circle? Yeah, that's a closed figure. So what we want to do is we want to find the distance around the whole entire circle. So, I don't know, let's just start at this point right here. We'll call this point A, all right? So if I went from here and I went all around the whole entire circle and back to A again, everybody see that? That's the distance around the whole circle. With a circle, we don't use the word perimeter, okay? They have a special word that they use that is not perimeter, and here's the word. It's circumference. Yeah, it's a common word. It's a word that they probably taught you back in middle school. All right, circumference of a circle. What does that mean? It's the distance around the whole entire circle. All right, and we have a little formula for it. The circumference is equal to, we can write it 2 ways. Let's write it like this. 2 pi, what in the world's pi? 3.14, that's right, okay? Pi is a Greek letter of the alphabet. Kind of looks like that. And that's how I write it anyway. So it's 2 pi r. That's the circumference of a circle. All right, so let's write it a little bit, instead of writing the whole word out, we'll just put C equals 2 pi r. Do you remember what we said earlier what the diameter was equal to? I put it in a box. Did you write it down?
Yeah, B equals NS.
No, for the diameter, 2r. The diameter is twice the radius, correct? So look, I got a 2 and an r right there, don't I? I got a twice the radius. So what's another way do you think I could write the circumference? Instead of 2 pi r, what if I knew the diameter? No, pi r2 is going to be the same exact thing. Remember what this is? So look, if I have a 2r, what can I replace it with? A d. That's right. So I could call this pi times diameter. Okay, I'll put a little or right there. When are you going to use one over the other one? Well, if they tell you the radius, I would use this formula. If they tell you the diameter, I would use this formula right here. It's the same thing. It just depends on what they tell you. Everybody got me on that? All right. I got this whole thing about pi, but I'm not going to do it now. I'm just going to do a couple examples, and then we'll be finished. Okay? So let's draw another circle. Right there. So here's an example. This is kind of stuff you see on our homework. This is kind of stuff you'll see on a quiz or a test. This is example 5. If you want to look in the book, I don't know why I did this time, but I wrote it in my notes. It's page 34. I don't usually do that, but I did for this one. All right, so here's what they tell you. Let's put the center in here first. So the center is about right there. And they tell you that that is what? What is that right there? That's the radius. All right, I'll put R for radius. And they tell you the circumference. The circumference is 10 centimeters. Okay? And they're going to ask you to do a couple things. They got a part A and a part B. Once we get done part B, we'll be finished. All right, so part A says find the radius. All right. So what in the world are we going to do here? Find the radius. And I got the circumference. Well, do I have a formula that has circumference and radius in it? Look at your notes. It's probably right there in front of you. Yeah, I got one. Its circumference is equal to what? 2 pi r. Okay? So yeah, there's circumference, there's radius. So which one do we know? Which one do they tell us? They tell us the circumference, don't they? All right, so where are we going to put that in our little formula? I got people still not looking up here paying attention. And I'm doing an example, something you're going to see on your homework and something you're going to see on a quiz or a test. Don't understand why you wouldn't pay attention. So Zion said it, it's 10, circumference is 10, equals 2 pi. I'm going to keep that pi for just now until I get the radius by itself. It's just a lot easier to work with when it's just a pi. All right? But what does it represent? What does pi represent? 3.14. Now, it does keep going. 3.14159, blah, blah, blah. I don't know what's after 9. I just have it memorized to that. But that's what we're going to put in. Why did I put squiggly equal sign? Why didn't I put just a regular equal sign? Is it exactly 3.14? No, it's what? What does the squiggly equal mean? No? It's approximately. It's approximately equal to 3.14. I used to have this poster when I first started teaching, and I kept it in my room for like 10 years until it fell apart. But it didn't go all the way around the room, probably went 3/4 way around the room, and it had pi taken out to maybe like over 100 decimal places. All right? If you put it into a calculator, it'll take it out to what, 8 decimal places or whatever you got on your calculator, 6, I don't know what it is. You could type it into the computer, give me pi up to 100 decimal places, and it'll give it to you, all right? We don't care about 100 decimal places, okay? The second decimal place is good enough for us, so we're just going to use 3.14. If you're using a calculator to do this stuff, which you can, I will let you use a calculator for this, don't use the pi button on the calculator. There is a button on the calculator that's got a pi symbol on it. Don't use it, because it'll take you out to like 6 to 8 decimal places depending on your calculator, right? Just use what? 3.14. So if you use a calculator, type in 3.14. All right, enough of pi. Let's keep going. What are we trying to solve for? We're trying to solve for the what? The radius, which is r. So let's do some algebra. All right, this is why we learn the algebra. Let's get r by itself. So that means I have to get rid of the 2 and I have to get rid of the pi. So those are being multiplied by the r. How do I get rid of it? I divide it. Divide it by 2 pi. Divide this by 2 pi. The 2 and the pi cancel. R equals. Now watch. Let me show you a little trick. Instead of putting this in your calculator, you can simplify this, a little bit of this in your head. What's 10 over 2? 5. Okay, but where is the pi? Is it on top? It's on the bottom. So we're going to divide. So what you're going to do is you're going to put this into a calculator and then figure out what that is. And I've already done it, and it's 1.59. And this is in centimeters, so what's the radius? Centimeters. So here's how I'm going to write my answer. I'm going to write r equals 1.59 centimeters. And that's how you would solve that. What if they give you another one, but this time they tell you, this is part B, find the circumference again, so find C, of something with a diameter of 60 feet. They don't draw a picture, but they just tell you the diameter. And they ask for the circumference. This is actually easier than the first one. Okay, don't pack up. I haven't dismissed you. So watch. Circumference equals. Now they give you the diameter this time. What was that formula with the diameter? Pi times the diameter. That's right. So look, it's very simple. This one's easier than the first one. Pi, or circumference, equals pi, which is 3.14. I said don't pack up, and more people are packing up now than ever before. You just don't know how to follow instructions, do you? Times what? Times 60. All right. Again, put it into a calculator. I can't do that in my head. Put it into a calculator, and you get 188.4 feet. So here's your homework. It's 16B. I gave you a lesson plan yesterday, but I'm going to write it down anyway. And you're going to do 44 to 53. I think that's what I gave you. Nope, I lied. Because I didn't give you all that stuff yesterday. It's 31. It's 31 to 53. We're going to go over both of those. So tomorrow, bring in 16A and 16B. All right? 31 to 53. That's what I have on the lesson plan. 43. Sorry. 43. I'm really messing this up. There you go. It's on the lesson plan. Just follow the lesson plan and you'll be good.